Okay, remember, mixtures are physically combined. Compounds are chemically combined. Since mixtures are physically combined, we can use a bunch of different laboratory techniques to separate mixtures. That's what we're talking about today. Pause the video if you want to read these. I'm just going to move on. Okay, first, mixtures versus compounds. So mixtures are two or more substances physically mixed. Compounds, two or more elements chemically combined. Properties. The properties of a mixture reflect the substances it contains. So salt water has properties of water and salt. For compounds, the properties are very different from the elements that make it up. So the properties of hydrogen gas and oxygen gas are very different from the properties of water. The composition in mixtures, the components can be present in varying proportions. So can be, when you take a bite of a salad, it's not the same all the time, okay? And a compound has a definite composition. Mixtures can be separated physically. Now, not all mixtures can be separated the same way, but we're going to talk about some ways. And compounds can only be separated chemically. All right, so we use physical properties to separate mixtures. So however they're combined, we kind of undo it with certain techniques. So one is filtration, okay? So now if you don't use filter paper and instead you just have some solid that's kind of collected at the bottom of a beaker, for example, what you can do is slowly pour off the liquid. That's a different process called decanting. Okay, and that can separate most of the liquid from the solid, but filtration is going to be more precise. You're going to use some kind of paper, pour the liquid into that filter paper, which is going to collect the undissolved solids and allow the liquid to pass through. So if I took soil and water, for example, to filter it, the water would pass through, the soil would stay on the filter paper. Okay, so this is a way to separate based on particle size those undissolved solids. The undissolved solids remain on the paper, the liquid passes through. Now, if I have sand and water and salt and I've mixed them all up, the salt is going to be dissolved in the water. So if I filter it, the salt water is going to go through and the sand will be on the filter paper, but I still haven't separated the salt and the water, okay? Okay, a mixture of sand and table salt can be separated by filtration because the substances in the mixture differ in, well, if I'm asking about filtration, the only right answer is because they differ in solubility, how they dissolve in water. Another technique then is evaporation. So I can separate something that has been dissolved in a liquid. The liquid will evaporate and the solid is left behind. You can see here is a salt farm, so I'm getting salt from salt water. Recovering the salt from a mixture of salt and water could best be accomplished by, remember you have to think about the salt is going to dissolve, so I want to use evaporation. Now distillation. Distillation is going to separate liquids based on their differences in boiling point. So I'm going to, all right, so you can see right here. Okay, so right here, I have a heat source, okay? And it is heating up this flask. And I'm going to heat that flask to the boiling point of one liquids and the lowest boiling point. So what will happen is that one liquid will boil and evaporate, and then that gas will come down here and condense, and now I've separated out this liquid. And what will be left here is the liquid that has the higher boiling point. And I could do this successively if I have more than two liquids combined. So petroleum can be separated by distillation because the hydrocarbons in petroleum. So why can we use distillation? Remember, you have compounds with different boiling points. And the reason it's compounds and not elements is it says hydrocarbons. So those are compounds that have hydrogen and carbon, so they're not elements. Chromatography. Chromatography, you can see, allows us to separate based on size and polarity. So different size molecules will move up the paper faster. Smaller ones move faster. Ones that are soluble in the liquid, the medium that we're using, will move faster. Ones that aren't soluble are kind of being stuck at the bottom. Okay, it's often used with pigments. All right, so in a laboratory investigation, a student separates colored compounds obtained from a mixture of crushed spinach leaves and water by using paper chromatography. The colored compounds separate because of differences in, so why again do they separate? Either size, but that's not here. The other one is molecular polarity. All right, we can also use a magnet, and this is probably less precise, but still effective. So we can separate based on magnetic properties. So if I take a bunch of sand and mix with iron filings, I can pull out those iron filings by using a magnet, and I've separated the iron from the sand without having to do anything more complex than that. Okay, so when sample X is passed through a filter paper, a white residue Y remains on the paper and a clear liquid Z passes through. So I take X, pour it through, Y stays on the filter paper, Z goes through. When liquid Z is vaporized, another white residue remains. So what was sample X? A heterogeneous mixture. How do I know it was heterogeneous? Well, I could filter it, and some stuff got stuck on the filter paper. So if stuff got stuck on the filter paper, it was not uniformly distributed. And by which process is a precipitate most easily separated from the liquid in which it is suspended? Filtration. Okay. All right, in class, we're practicing with the blue kit. Super fun. So this was a review of the laboratory techniques we can use to separate mixtures. And we can separate them, remember, because mixtures are combined physically. So we can separate them physically. And so there you have it. I hope you learned something new today.